Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today, I will be taking a stop looking at Apache because I kind of got bored of that and looking at mail servers. Just compiled and set up Postfix, so let's get started. Where? Yeah, here I started Postfix, and we can see that when I listening on port 25, which I believe that's a standard SMTP port. SMTP port. Yeah, port 25, cool. Just for standard unencrypted SMTP. And thing is, when we just connect to it with Telnet, which with clear text protocols, you can just connect to it and start sending SMTP commands. We see that we're able to actually interface with the server so it is up and running. I'm not that familiar with SMTP protocol, so I won't be able to fully send it from the command line, but yeah. First thing that I'm going to want to do, it's running, I wanted to locate where the binaries are. So, I just script for postfix. Now we see here, master's right here. I'm assuming this has a model where it has like a master process which manages the other processes, and it will just spawn a process to handle some of the work, such as oh hey, receiving an email, sending an email, that sort of stuff. One thing to note here, master process running as root, the rest of the processes are running as the postfix user. We can see that there's proxy map, SMTPD, queue manager, and pickup. So it looks like there's multiple different binaries that are composed within postfix that it uses. And let's just start taking, I'm going to start taking note of what we see here and then continue looking through there. There's, actually I wonder. Yeah, we see master pickup queue manager SMTPD and proxy map, which when we look under the user libexec postfx, we see actually we see master pickup queue manager SMTPD. So I'm pretty sure that all of the various different binaries that postfix will call upon are located in the user libx postfix directory. I want to see, are these actually binaries or are they just like scripts or symbolic links somewhere else? Well, the fact that the green means that they're all marked as executable. Okay, so they're all binaries. Okay, cool. Hang on one second. Okay, cool. So first, master. Let's take a look at the postfix source code real quick. Pivot to there. Let's see what that looks like. Okay. Looking at here, I'm seeing that there is a correlation. We see like pickup here, a binary, and then we also see pickup as a directory there. Queue manager we see here, which queue manager LSS and TPD. Yep, that's okay. Cool. So from what we're seeing here, something a bit interesting. Postfix when you looked at Apache, it was primarily just like one binary, and it would like load in other modules and stuff like that. Here, it looks like it's just primarily, yeah, look, it's like, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. It's like 30 to 40 different binaries, each composed of their individual source code, and it looks like those binaries interact with each other to accomplish the goal, which is cool. And we also see there's a master. Okay, this is interesting. Also, it appears that the binaries are present in the source. Cool. So that, let's start taking a look. Let's just take a look at master.c first. Now, what I'm trying to do here, what my ultimate goal is to roughly understand how Postfix works and where the different code paths are that interact with each other to accomplish arcs. Not arcs. What I mean by an arc is like a task like, oh hey, getting an email or sending an email, something like that. Now, what I'm hoping to do here is look at a few different mail servers and potentially do vol research on them, maybe find some bugs and report them to the author or something like that. Cool. But yeah, let's look at, no more Apache reversing for now. Postfix. Where am I going? Source. Master.c. Okay, so this is the main function of the main program. Okay, since it's the UMask process environment variables, don't die when a process goes away unexpectedly. Yeah, right now, so this is where main functionality of Postfix where it starts. Since I'm assuming that the master.c, that's the first process that's actually spawned, and this is the main word, which is where the code actually starts running. Initialize logging and event handler. Check postfix library version. Process. I'm assuming these are command arguments passed to it. Takes no other arguments. Sanity check. Running a separate process group so the postfix stop can terminate all. Make some room for plumbing with file descriptors. Okay, so multi-protocol support this done master. Okay. Lock down the master.pd file. Lock down. Clean up. Debug. Okay, this is interesting. Looks like it has some sort of like built-in debugger. Not sure what functionality that will have for process events. The event handler will execute the read-write timer. Looks like this is a loop that will run infinitely. Refresh. Master frozen. Mail log client init. So it looks like this main function will handle most of like the events that come up. Okay. Okay, cool. Since right now I'm kind of interested in looking at, so looks pretty similar to what I expect, manages other processes, doesn't actually do the work itself. One thing I'm kind of curious to look at next is smtp.c. or yeah, smtpd.c, because I get the feeling this is where a lot of the work with smtp actually happens. smtpd.c. Oh, this is a long config and okay, looks like these it's storing a bunch of constants as well in these two arrays, config and table config. Okay, this is single server pass control to the single threaded service skeleton. Okay. Hmm. I'm going to pause this stream for a second. Okay, I'm back. So, Postfix obviously is a somewhat large target, maybe like medium size, depending on like what the exact pool you're looking at. But here's the thing, right now we're trying to reverse out bits of it, and we have to make sure that the reversing stays relevant for that, and that you are actually getting value from that reversing, since you can literally spend like the next year reversing at random bits of this and not have it really help you that much. So what am I interested in? Right now I'm kind of interested in the like SMTP attack surface, which means, oh hey, where does it take our input and where does that input end up? Cool. For that, I'm kind of assuming it's in the SMTPD process. Now, okay, our SMTP connection was closed. We can tell that here. Let's take a look. Postfix. Okay, we can see that SMTPD process has been killed. Let's try connecting again. Okay, we connected to the SMTP server, and we see here an SMTPD process and a proxy map process have been started. I'm going to go ahead and connect to the SMTPD process. Sudo g2b attach 30518 poll timer read. Okay, main server made event loop SMTPD. Okay, so we're seeing here attacks. Oh, not attack surface. A call stack about 10 to 20 functions deep. vbuff SMTP get. Okay, primarily this right here. SMTP get called by SMTP check query limit. Let's take a look at this function right here. So also let me explain the current state of the program right now. We attached to it right now. SMTP is waiting for us to send anything, because if you look over here, oh yeah, I probably just had my cursor on the wrong screen, but oh well. If you look over here, we see that our connection to the SMTP server is still available, meaning that the server is still processing it. And we see here polling, it's just effectively waiting for input. So this is a good spot for us, since it will tell us exactly, oh hey, this is where your data, where it originates from. And looking, just telling by the names of the functions, SMTP gets probably the function abstracted away where it will get data from an SMTP stream. And I'm guessing one of these three functions is where where it starts like evaluating the functionality, well, evaluating the contents of the SMTP traffic. Let's take a look here. Actually, let's just grep through here. We're in the SMTPD. Oh, SMTPD. Grep IR. SMTP chat.c. Let's open that up. SMTP chat.c. Okay, doesn't appear to be that big, only like 300 or so lines. Let's look up SMTPD chat. Okay, what was the function we're looking at? SMTP chat query limit. Receive and record an SMTP request. Gets it? State. Looks like there's an SMTPD state, which is what actually will probably store the request. State client, state buffer. Okay. SMTP chat append. In request longer. Okay, does not. So it looks like this function effectively just calling other functions, which will handle the effort of scanning in the request. So it's probably, this isn't where it starts evaluating it, which is right now what I'm curious of the functionality. It's probably SMTPD proto or SMTPD service. Let's look at proto first. SMTPD.c. Oh wait, we already have that open. Okay, let's look for this. Duplicated from. Okay. Talk the SMTP protocol. This looks good. Let's copy it over. Yeah, it looks like that has a ton of functionality behind it. About 400 to 500 lines of code. Let's start looking through here. Print a greeting banner and run the state machine. Read SMTP commands one line at a time according to standard. SMTP stream setup. Message panic. Oh, if whatever timeout exceed. Okay. Wait, there's a switch status. While status equals vstream set jump. Okay. Default case SMTP time error. I'm curious if what is happening is, so when you did the telnet connection, we didn't actually start sending commands. What it looks like it might be going on here is first it sets up a connection and then starts actually processing, just talking. For this, what we can do is we can assemble SMTPD proto. Oh, this is not the debugger. Where's my debugger? Here it is. Proto. Cool. Let's scroll. It's going to be near the top. It's going to call vstream set jump. Where is SMTPD stream setup? Call. set jump. Where? Okay, something strange is going on. VStream set jump. It might be 6 set jump. Okay, yeah, it makes sense that this is it. So I want to set a breakpoint for here. The reason why I don't want to set a breakpoint for the actual function itself is in case if it's called somewhere else, I want to break it right here. So let's set a breakpoint there and continue. So it's called from here. Hello, hi, hello. Is there another process that started up? It's not hitting breakpoint. I'm wondering why that is. Pipelining. Maybe I have to start sending actual requests. So also something else that's a bit interesting is I closed the connection, yet the process is still running. Why is that? Some TPD. Okay. Hello, hi. Okay, so one thing I'm noticing, I'm sending several different commands, but I'm only triggering the breakpoint once per actually connecting, not actually sending in commands. And looking at, where is a terminal? SMTPD. Looking at SMTPD, there's only one process which I'm currently connected to, which tells me either, so this is the only process that, assuming my previous assumptions and current idea of how this works, this should be the only process that actually handles SMTP traffic, which either means one of two things. Either number one, the spot that I thought of right here potentially, or this function being the one that actually handles SMTP traffic, that's either false, or there's some sort of like command filtering to actually validate if commands are accurate before it hits here, which I'm thinking it's more or less just the actual logic of where it is different. Let's try breaking. Where are we here? According to this, it's called from SMTPD protocol 5648. Query limit. SMTP.c line 5648. Let's take a look. Where is that? 5648 SMTP chat query. Wait a second. Chat query state if a lot of if then statements here. Use TLS break. There's an infinite loop here. What are the exact bounds in this infinite loop? This infinite for loop. Wait a second. For. Oh, it's right here. the command smtp chat reply. Check. I'm curious, how often does this right here get hit? Delete one, break it. Hello, hi. We ran it, got hit again. So it gets hit every time you send it. So this is definitely part of the code path where it scans it in. And also we see, since we can the make file that we have automatically had debugging symbols enabled with the debugger, we can see, oh hey, it's with this line, it's exactly 5650. Okay, so right here. Safety protect internal interfaces against malformed UTF-8. So this just appears to be a simple this right here appears to be just a simple check against for valid UTF-8 sent. Let's continue looking through. Move into SMTPD check query and update. SMTP token. Is this where it tokenizes the string? So what tokenization of string is, like, let's say you have, like, for instance, a something like SQL, where SQL code, what it will be is you effectively just send it some text. It could be like select all from table name or something like that. It's strings that represent meaning, and tokenization is effectively a way, depending on the format, if you just pass a computer program a string, it can have a hard time understanding that. So what it'll do is it'll try to like transform those strings into like tokens or value, like numbers or something like that, since it can interpret that better. I'm curious if this string token or SMTP token right here is random hit every time. It's hit that time, send garbage, hit there, and we see that the arguments passed is the, yeah, it is the string that we passed. So it is doing string tokenization on our input. argv. Let's take a look. I'm curious as to, wait, is this function SMTPD token? Looks like it has its own source code file. SMTPD token.c. Okay, cool. I want to know where token init SMTPD. Okay, so SMTPD token takes two arguments. The first is the char pointer of the string it needs to tokenize. The second is the SMTPD token, which it will use to store the tokenization of the string. So looking back at this, we know that argv, this effectively is a tokenized version of whatever command we sent it. So that will help with looking this over. And this is just an error check in case if it can't do it. Now, pretty sure this is going to fail since we didn't actually send it proper. Okay, that was a bit of a, so didn't get caught by this bad syntax check, it looks like. If ignore smtpd noop commands, look up errors, non-critical features. Okay. Ignore. Okay, so looking like these checks here are just looking for commands I can just flat out ignore. Use real client for connect. Chat reply. Where does it actually start looking at? Indirect call, interesting. CMDP, where does CMDP? Actually, we have it here. No, this is not the file. Is this the copy of? Yes, this is the copy of it. I'm just going to see where argv, where it's referenced, since that is the tokenized version of our input. It's going to look at that to determine what our input is and what to do. Looks to see if it's a noop command, which you can just ignore. CMDP equals string. Not quite sure what's doing there. Ignore stupid forbid command lookup. Okay, ignores more commands. Okay, I get the feeling that this CMDP action is where it actually will evaluate our input. Reason for that being is looking at all of the other places is where it's referenced in this function. It appears to just be simple checks to see if it can ignore work or report an error. Now CMDP action, this is not a function itself, it's an alias which has a function stored in it. So what we can do is we can just grep for cd hackery postfix smtp and then action. Looking for like an action equals, unless this list is just, no, it's not too big. DNS action equals delivered, relayed. So like any. Okay, this is interesting. That is not giving me the results I hoped for. What is CMPD equal to? CMDP equals SMTP command table. Okay. Oh, this is starting to make sense now. Okay, CMDP is set equal to SMTP command table, and if it compares against the name of the command with the type of SMTP command it just breaks. And then probably down here is where it will actually, where is it? No, yeah, CMDP action, that's probably where it'll actually call the corresponding function to deal with whatever command that is. Cool. Now, I'm curious, what is this SMTPD command table? Let's find that, since that will probably... No, that's the wrong file. Okay, cool. So this is the function. So there's command hello, command hello, x client, x forward start. So it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 different commands that we can use for this. Now, what I'm going to do, hello and LO are right now the only SMTP commands I know off the top of my head. So I'm just going to try maybe delete 3. Set a breakpoint for SMTP. Actually, first, is this a symbol that we can resolve? the command hello command. Okay, so looks like SM. I'm not sure what the format is. Looks like hello with these hello. The first argument, I'm guessing, is probably just like the name of whatever command it is. Second is the function. Why is it the function? Because I can just take that and that symbol will actually resolve to a function. So let's set a breakpoint for the hello command. And let's say hello hi.com. We run that. Okay, cool. It runs. And it runs from this SFTPD proto service, which I get the feeling that if we were to I'm gonna just call 5. What I'm right now trying, actually, wait, can I? Hang on. I'm trying to see what the previous command was. Can I do like -1? Okay, cool. So I can do that. Interesting. We can see that the previous one is an indirect call, which is what we'd expect it to be, based upon the fact of it looking at. Actually, I'll just show you. CMTBD action. Yeah, this right here is an indirect call, since this CMDP action is not a hard set value, it changes. And now, cool, so we know that. I'm gonna just try sending another just garbage to see. We see it doesn't work. Hello. Another command does not cause hello. But if you do say like hello, cool. So we have You have successfully identified where in Postfix the where it actually scans and starts processing various commands. This has been going on for 37 minutes, so I'm going to cut it off here. Thank you for watching.